Hi, my name is Emmanuel Garces. I work for Wolfram and I do geographic visualization functions. Today we're going to talk about that. The talk will cover a survey through the data we have, including vectors, and through the functions we have developed to visualize that data. Hello, my name is Emmanuel Garces. I will be talking about geographic visualization. Um, I work for the visualization team with Brett and the rest of the team. Um, okay, yeah. The talk is mainly focused on how data is going to give us the information to feed the 9 visualization functions for geographics. I mean, we already have 9 of them. So we essentially have 3 different types of data. Geoposition or geoentities with a position, geoposition and entities with geoposition associated with values, and vectors. So there is also a Twitch talk. Here's a link. I will upload this to Table, so you will be able to see this Twitch talk. Okay, the first of the geographical data we have is geoposition or entities. We start by showing how can we use this kind of data by using Geo Plot. That is essentially the Geo version of list plot. So we can feed Geo Plot with entities like say the Gobi Desert, or using a Geo variant of the United States showing all the areas, or just a random a random geoposition, right? So here we are showing points for those like geopositions or Gobi Desert, right? And showing a polygon for the United States. So we can mix different kind of inputs. Typical example of using GeoList plot is showing points on a map like the highest 30 New York City buildings. So in this case, you can see we can use Wolfram Alpha input. So GeoList plot and basically all of the geographical visualization functions accept this kind of inputs. Right. Another function we can use by feeding it with inputs that are geopositions or entities is geohistogram. Here we're showing histogram of 300 random geopositions on Australia, right? And we are using the default binning, it's in hexagons, right? We can set different bin specifications like an administrative division showing us how many points are in each of those divisions, or we can use different bins like triangles or rectangles. There are more different specifications for bins, but that will not give us. We have not enough time for that, right? Okay. Of course, we can use data from Wolfram Alpha. If I click here, you can see the interpretation of this. Okay, so we are basically using the parser from Wolfram Alpha, right? So here we are showing the largest 100 cities in the United States. As you can see, there are a lot of cities right here, but probably not with the same population, right? So later we will show how we can use geohistogram with positions associated with values, in this case, population. Okay, we can specify different bin, as I told. In this case, we are using the US state, or probably a zip code for the 30 top city buildings in New York, right? So basically, that's GeoHistogram. What GeoHistogram does for inputs having entities or geopositions. Okay, we have a continuous version of GeoHistogram, and that's GeoSmooth histogram. It's essentially based on the smooth kernel distribution of data. In this case, we are showing the same input we showed for GeoHistogram. Now we are showing the 300 random geopositions in Australia. The same for the cities in the USA. You can see the density of cities, of position of cities, are in those two parts, right? We are not using population yet, as you can see. Is there
a contour version of that?
Yeah, we will. GeoSmooth histogram has different settings. One of them is changing the bandwidth of the smooth kernel distribution, or using different methods for calculating those bandwidths and so on. Okay, and as you can see, the plot goes inside the ocean, so we can specify the region we want to include in the plot. So we are constraining the region function to the United States, right? Okay. Yeah. Yeah. Okay. The second kind of data is geoposition or entities associated to values. Of course, those entities have to have the property position, because we want to relate a position or a coordinate to a value. So the first function I'm showing here is GeoRegion value plot, and I'm plotting different countries and some value, right? And the value is colored by using some color function. We can also use quantities, or as you can see, you can use Wolfram Alpha input. So we are associating again entities with quantities. In this case, those are the exports of oil of each of those countries. Another way to visualize this kind of data is by using Geo Bubble Chart. A Geo Bubble Chart, as you can see, shows bubbles whose size or whose area. By the way, we can set it to be proportional to the area or the radius of the bubble. So we can see each bubble is proportional to each value associated to each coordinate, right? Okay, so the bubbles can be anything, as long as we can see how proportional those bubble size are. In this case, we are plotting the same countries we showed earlier, but we are showing a pie chart comparing the oil consumption. The size of the bubble is the oil consumption, and the yellow area is the blue area is the production. So in Japan, they don't have that much production, but have a lot of consumption, right? Okay. So as you can see, the sizes are very different. And in China, we have the half, sort of. Okay. Let's see. Wait, I think I got into the. Where am I? Yeah. Okay. We are back to geohistogram, but now we are using coordinates associated with values. In this case, we are now associating the top 100 cities of the USA with their population. Now we are using weighted data. We can use many kind of different specifications for the input. In this case, we're using weighted data. Now we can see that the population in this area is not that big as the population in this area, right? In the other use of geohistogram, we saw that we had a lot of cities here. But if we add up all of the population, we have more people here, right? Okay. So there are some inputs that doesn't make sense, right? For geohistogram with weighted data. Say, for instance, if we want to try to make the same for the highest 30 New York City buildings, we got something strange, right? Because we are adding up the heights of each building in each bin. And unless you want to have a measure of how many concrete are there, or I don't know, yeah? But we can do that. Okay, we're back again to geosmooth histogram, but now using the associated data to coordinates. So in this case, you can see that, effectively we have more people here, right? Okay, we can also use the region function. And there are what is coming next. We have a Geo Density Plot, and I have put this here because it also accepts positions associated with values. So Geo Density Plot is the geo version for density plot. In this case, I'm showing an example showing the ozone in the world. As you can see, well, this one is correct, right? Wait, because here we have associated heights to the coordinates of the opposition. So we are assuming that these objects have coordinates, and each coordinate have a height associated. We know that ozone is not a height, but we can deal with that as it's a height. Okay, and here is the plot. We just have to say type geodensity plot of this object, and of course we can apply different settings for it and have this nice view of how the ozone was and that particular date. I don't remember the date. Okay. As I said, we can use geo-elevation objects with some heights specified inside the object. As we can see, we have the height bounds here, and this is the elevations for Creature Lake in Oregon. So we're using density plot to show how those elevations look like. Okay, by the way, this line here is ferry trip, I think. So that's that's new in the new Geo server. So we didn't have that before. If you just ask what this line is doing here, right? Yeah.
Is there scale or legend that is there for what color corresponds to what elevation?
Sure. Sure. It is. Okay. Yeah. Yeah. We can use that, but setting the plot legends goes to automatic. Yeah. Yeah. We can do that, and of course we can change the color function scales and so on. Okay. Here comes Geo contour plot. Geo contour plot is also coming soon. It's essentially the same that we do for Geo Density Plot, but we are showing the contours as we have for least contour plot. In this case, I'm just using. Okay, this shouldn't be here, but okay. I have elevations and the same Crater Lake example. So as you can see, we are showing the elevation of each contour, and here we have nothing, right? But what happens if we change the number of contours? As the data we have has a really good level of zoom, we can see that we have some, let's say, irregularities inside the lake. So we can go further in more detail for the contours to be shown, right? Now, by default, we don't have any shading here, but we can set that up. So in this case, we are using a shading. Of course, each color depends on the color function and on the value, right? And as I said, we can change the color function. So those are basically the functions that uses our entity or a geoposition associated to a value, right? But we have a third kind of, okay, before going to that, as I said with the buildings example, we have to be wise about choosing what function to use, right? Because we can imagine a New York like each building being an elevation or a mountain or something. Probably that could be interesting somehow. I'm not sure. But anyway, we have new functions and we have data, and we can experiment by just feeding that data into the new functions and see what those look like and if it's interesting for us, right? Okay, now, yeah. The third kind of data we have are geographic vectors. Okay, we have the first function that uses that data is GeoVector plot. GeoVector plot essentially takes a GeoVector object like this one. Here I'm just making an association of random geoposition objects in Europe to a random vector consisting in magnitude and an angle, right? That's the bearing angle. Okay, so this list looks like this one. That's a position and a vector. And then we plot this, and we have this vector plot on the map. And of course, we are using the new styling that Brett just showed. We can, of course, make different settings here, as Brett just showed. But I just want to show this example. I'm focusing now in data, because GeoVector plot also accepts GeoVector E and U objects. So those are, this E and U stands for east, north, up. So we have a vector with 3 directions, yeah. And I'm just showing again a random example showing those vector E and U vectors or geovectors in the world, right? And the third kind of vector.
So this is two-dimensional effect, so it's just east north.
Yeah, there is no not up here, but we can set that. Yeah, probably. I don't know, but in the future we could have a 3D version of GeoVector plot, right? Probably. Okay, GeoVector XYZ as the same as GeoVector ENU. We have okay, again we have something like this, the X and the Y and the Z directions, and we are putting here just a random example. Okay, GeoStream plot works the same way. It also accepts GeoVectors, GeoVector E and U, and GeoVector X, Y, Z, right? This doesn't need to have any change, right? Because GeoStream plot just shows the streams according to some vector field, right? So that's what we actually have for GeoStream plot. And I'm not showing more examples showing GeoVector ENU and GeoVector XYZ because it's the same input. Right. So let's go to some applications. Say we have the positions of wind farms in the USA. So as you can see, those are the points here. And then we can use GeoSmooth histogram to see where are the locations. Then we have more. So of course we have a lot of them here, right? Okay, but now we can get the vectors for the winds from wind vector data. In this case, I'm saying just get 200 random geopositions in the USA and get the downwind geovector now, right? I'm not going to evaluate this. It sometimes could take some time. Okay, I did that already. And then we can, because this one returns us a geovector object, we can go directly to GeoVector plot and then have this this map with vectors. Of course, here I don't have the new styling, but we should, right? I just evaluated this in an older version. But what we can do after having those both plots, we can just combine them and show the density of the wind farms and how the vector winds are, right? Again, you can here set different options. You can set, you can make it more attractive anyway, but what is important is that it's possible to do it. The last application I have is geomagnetic data. I mean, we have geomagnetic model data. Of course, I'm getting that, and I'm getting also a geovector object. Now, okay, I don't want to describe this input, but we are essentially showing the stream of the vectors of magnetic data at the North Pole. So we have, three different points. This one is called the North Dipole, is where exactly the magnetic vector is, say, totally vertical, right? This one is the geographic pole, the North Pole, and this one is the geomagnetic North Pole. It's like the one we see when we see the world with a big magnet on it. And I think that's about it.